Okay, today we're going to take a look at naming ionic compounds. So far we've looked at how do ions form, how do we form an overall neutral ionic compound. Now we're going to look at how we name them. Before we do that though, we're going to take a look at some review. Review of ionic compounds. Ions form when atoms gain or lose electrons to become stable. So atoms are lazy. They are going to do the easiest way. We're trying to get 8 outer electrons and they're going to lose or gain based on how many outer electrons they have. So if they have 1 outer electrons, the easiest thing for them to do is to lose that 1 electron and kind of go back an energy level. If we have 7 outer electrons, it's way easier to just gain 1 more to be at 8 than to lose those 7. In order to become even more stable, these positive ions, the atoms that lost electrons, and the negative ions, those atoms that gained electrons, bond in ratios to form neutral compounds. So let's do an example. Sodium and nitrogen. Sodium's formula is Na. Nitrogen's formula is N. Sodium has a +1 charge. Nitrogen has a -3 charge. Neutral means that we're looking for no overall charge. So right now if we had our +1 and our -3, we'd get an overall charge if we added those together. -3 plus +1 would be a -2 overall charge, which means I need more positives here, right? I need more positives to be able to balance out this negative. So I add 1 more. Now I have 2 positives, 3 negatives. So that still gives me a -1 overall charge. So I add 1 more sodium atom. Now I have 3 sodium atoms, 1 nitrogen atom, and that's how I get my subscripts, Na3N. Now I don't need that 1 subscript there because we can just ignore it. We just don't need a 1 there to tell us that there's 1 of those. Okay, so moving on, how would we name this? The naming actually ends up really easy, but we need a general formula for it so that when we talk about ionic compounds, everyone knows what we're talking about. The positive ions, so those are always the ones that come first, we get the name straight off the periodic table. So in our last example, Na would be sodium. Our negative ions then is the name off the periodic table, but we change the ending to IDE. So N, our nitrogen, becomes nitride. See this IDE right here? Okay. Now, how much we chop off is different for each atom. There's no like, oh, it's the last 3 letters or anything like that. If you get it wrong, but you knew it changed to IDE, we'd probably take it in a quiz or a test. Also, if you say it out loud and it sounds funny, you're probably wrong. Okay, nitride sounds okay, but nitrogide sounds weird. Okay, we'd go with nitride, not nitrogide. So our total for that Na3N that we had last time in the last slide would be sodium nitride. That's how we'd pronounce that. Let's do some practice. We got Mg3P2, Li2O, and CaCl2. So first we're going to look at what are those positive charges. We have Mg plus 2, Li plus 1, and Ca plus 2. We got those straight off the periodic table. Because these are our positives, right, they're all positive there, we just look at the name on the periodic table. Magnesium, lithium, and calcium. Okay, now we're going to look at our negative ions. We got P minus 3. That's phosphorus, but because it has this -3 charge, I'm going to change it to IDE. Okay. The O with the -2, we change oxygen to oxide. And then the Cl with the -1, we change chlorine to chloride. So our overall names end up being magnesium phosphide, lithium oxide, and calcium chloride. There are a couple other practices on your worksheet that you are going to go ahead and do yourself. If you have questions, make sure you're letting your teacher know.